So today we're expanding our factoring skills and we're going to learn how to factor expressions when a is greater than 1. A quick reminder from way back, way back, like last week, we were factoring quadratic trinomials like x squared plus 7x plus 12, where we had to find factors of 12 that added to 7. In this case, 3 and 4 was our factor pair. And then we broke it up into factors of x plus 3 and x plus 4. If I multiplied those together using distribution property, I would get x squared plus 7x plus 12. So today we're going to tweak that just a little bit, because today the coefficient on the x squared, which is called a, is greater than 1. Like 6x squared plus 16x plus 10. This time, instead of finding factors of 10 that add to 16, especially because there aren't any, we are first going to multiply a and c. Remember the standard form of a quadratic expression is ax squared plus bx plus c. So a is always the coefficient on the x squared term, and c is always your constant. I have to multiply 6 times 10 before I can start to factor. Since 6 times 10 is equal to 60, I'm going to try to find factors of 60 that add to 16. And our factor pair turns out to be 10 and 6. I can't immediately put those into our two binomial factors though. It doesn't work the same way. We've got to have a little intermediate step here. What I'm going to do with that 10 and the 6 is I'm going to break up my middle term, those 16 x's, I'm going to divide into 6 x's and 10 x's. I still have 16 x's there, but I'm breaking them up according to my factor pair. Now, order kind of matters here. The reason I put the 6x first and the 10x second is because 6x squared and 6x have a common factor of 6. And 10x and 10 have a common factor of 10. I want to try to keep terms with common factors together. I'll show you why in just a second. So from these first two terms, 6x squared and 6x, I'm going to do some greatest common factoring. They both share a 6, and they both have at least one x. So I'm going to pull out a 6 and an x from both terms. In the first term, I'm going to be left with an x. In the second term, 6x divided by 6x leaves me with 1. I'm going to do the same thing to the second set of terms. 10x plus 10 share a 10 in common. So I'm going to pull out the 10. The first term I'm going to have an x left over. And in the last term, 10 divided by 10 leaves me with 1. If you look at these two factors now, the factors in blue and the factors in purple, what do they have in common? What do they have that's identical to both? They both have an x plus 1. So even though we already did some greatest common factor factoring, we're going to do that again. And I'm going to pull out an x plus 1 from both terms. So if I take out the x plus 1, what is going to be left over in the blue term? It's only going to have 6x left over. And in the purple term, if I take out the x plus 1, what's left over? A plus 10. So I can write my factors as x plus 1 times 6x plus 10, or I can write them as 6x plus 10 times x plus 1. order doesn't really matter here as long as I have both factors. There is one more small step to this equation, but we're going to come back to it a little later in this video. So since we're kind of grouping terms with common factors together, this is called factoring by grouping. Please make sure that gets in your notes along with the examples today. Factoring by grouping is an important term to know. Let's try another one. I have 36x squared minus 54x plus 8. First thing I want to look for to make my life easier is common factors. You don't have to look for common factors up front, but these numbers are kind of big and all of these numbers can be divided by 2. So if I pull out a 2, I'm left with 18x squared minus 27x plus 4. These numbers are a little easier for me to work with. To multiply my quadratic trinomial, I'm going to multiply a and c. 18 times 4 is going to give me 72. Then I'm going to find all the factors of 72 I need to find in order to find a factor pair that adds to negative 27. And that's going to be negative 3 and negative 24. Which one of these factors out of the negative 3 and the negative 24 have a factor in common with 18? They both do. All three of these can be divided by 3. However, 4 doesn't have a common factor with both of them. It shares a common factor with negative 24 only. So I'm going to pair the negative 3 with the 18 since they share a common factor, and the negative 24 with the 4 since they share a common factor. Again, I break up the negative 27x. I still have negative 27x's here, but now I have terms with common factors side by side. Remember, the 2 is still out front. It cannot go away. Out of the first set of terms, the 18x minus 3x, I can divide both numbers by 3, and they both share an x. This is what it's going to look like when I divide both terms by 3x. In the second set of terms, I'm going to bring this negative or minus, of course, straight down. That's always going to come straight down. If that's a plus, I'm going to have a plus down here. The 24x and the 4 can both be divided by 4. So I'm going to factor out a 4, and I'm going to be left with 6x and a minus 1. Negative 24 divided by negative 4 is a positive 6, and positive 4 divided by negative 4 is a negative 1. Now, what do these factors have in common? They both share a 6x minus 1. So I'm going to pull a 6x minus 1 out from both. And in the first set of terms, I'm going to be left with a 3x. And in the second set, I'm going to be left with a minus 4. This is completely factored. This is what I'm looking for today. We're going to go over one more just so that we can make sure that we're doing everything we can. Remember, first, I multiply a times c. These do not have a common factor, so I have to just multiply 10 times negative 27. I get negative 270, so that's what I'm going to try to find the factors for. I want to find a pair of factors that add to positive 87, and that comes from negative 3 and 90. So when I break these up, remember, one of these numbers is going to have a common factor with 10, and the other is going to have a common factor with negative 27. The 90 and the 10 are going to go together, and the negative 27 and the negative 3 are going to go together. So when I split up the middle term, got a little ahead of myself, sorry. When I split up my middle term, I'm going to match the 90 with the 10 so that I can factor out a 10x. And I'm going to match the negative 3x with a negative 27 so I can factor out a negative 3. When I look at my factored terms, they both share an x plus 9. So when I take an x plus 9 out of both factors, I'm left with a 10x minus 3. And we're done. It's completely factored. One thing to watch out for as you're doing these factoring, if you factor and you think you're at the very end and you find that one or more of your factors has another common factor, you need to take care of that. So let me show you what I mean. Let's say I ended up with these two factors. Notice how the first factor has both a 4 and an 8. They still have another factor in common. So I would pull out that 4 and be left with an x and a 2. The right-hand side is completely factored. Or if I had these two factors, notice the first two numbers can both be divided by 3, and the second two numbers can both be divided by 2. I could factor both of them, but I can't have two coefficients, right? Can't have two common factors, so I would just multiply them together. 3 times 2 is 6, and then I would keep the 3x plus 2 and the 4x plus 5. So remember, we changed things up a little today. When you finish watching your video and taking the notes, you're going to take the quiz attached on Canvas. Did I say that wrong? Attached on Canvas to this video. Don't forget to take the quiz. That's where your video points are going to come from. Have a great day, and I will see you next time.